The EU-funded Labyrinth project started in 2020 to create and validate new swarm drone applications through research and development of 4D swarm drone trajectory planning algorithms for implementation in ground control stations and new U-space services, supporting swarm drone self-guidance to improve safety, efficiency and sustainability in civil transport.
We are 13 partners from companies, different research organisms and users. And in this project, what we are is oriented to the safe management of a set of drones, up to a swarm of 10 of them, in order that an operator can manage in a restricted area, a port or a station, in case of emergency in cities, in order to provide to all of these UAVs with the conflicted path in order that they can fly safely.
Labyrinth aims to provide a solution to the new framework designed by SESAR, called U-space, to safely and efficiently integrate drone operations at low level, below 120 meters in European airspace.
U-space is a recent definition of how the traffic of drones will be managed in Europe. For several reasons, this traffic cannot be done by controllers and has to be automated. And it can be seen like a coordination of services. In the Labyrinth project, we are implementing some of these services, some of the most key services, and we are testing them in real-life use cases. This implementation and test of the services will allow us to detect weaknesses and gaps in the use-space ConOps and suggest improvements to its definition.
Given this scenario, Labyrinth proposes the need to investigate new centralized planning systems capable of communicating with all drones in a given area, processing their desired origin and destination points, and calculating trajectories to avoid collisions.
This project has three main aspects from the technical point of view. One of them is the 4D path planning for obtaining the conflicted path planning, the conflicted temporary and spatially, the use of 5G communication to maintain a continuous communication with all of UAVs independently of the distance of the drone to the operator. We don't need to maintain a visual line or a radio link, a direct radio link, because we use the 5G communication. And also we have another strong part that is how to maintain the cybersecurity of the whole system.
The above technologies must be integrated into a U-space system that is capable of managing multiple UAVs in a single airspace. Therefore, these technologies are connected to the ground control station, which controls the scheduled flights at all times.
Dentro de lo que son las distintas funcionalidades que se van a desarrollar dentro del entorno de las necesidades de U-space, de los servicios a proporcionar, el INTA para el programa Labyrinth lo que ha hecho es utilizar las estaciones de control en tierra de los drones que normalmente ya utiliza el INTA y adaptarlos a las necesidades de comunicación para dar los servicios que U-space requiere. Nosotros lo que hemos hecho, por un lado, es modificar el software de la estación para dar esas funcionalidades y a la vez modificar el comportamiento de los drones comerciales, como son drones de DJI, para que también, modificando su software, su comportamiento con las funcionalidades que DJI te proporciona, poder también dar esas necesidades, pues dar información a U-space para que todo este escenario pueda tomar un engranaje perfecto en una operación multidrone con distintos tipos de actores.
Labyrinth will lead to applications in roads, airports, seaports, and emergency situations related to urban mass concentration scenarios. For this purpose, the developed technology has been tested in 4 different use cases.
Today we'll be performing the test on the use cases scenario for airport control. On the mission that we will perform today, we will use the SESAR UAV, which is a UAV shaped like a bird of prey, and we will be using for a mission for aviary control. So we keep the airfield protected of potentially dangerous bird strikes. On our second flight, we'll be performing a patrol mission taking care of the security of the airport. On today's mission, we'll be performing a flight with one UAV combined with two simulated UAVs. These three units will be reporting the information to the UTM, and we'll be negotiating their trajectories in order to avoid collision.
The maritime transport, two ports showed interest in using drones for the daily tasks. In the case of the port of La Spezia in Italy, that is a container port, it was their first contact with using drones for monitoring the loading operations or for their daily security and safety routines. For instance, they could check that even when the drones need to fly very high over the cranes in the port, the quality of the images that they could see, it fitted perfectly with their needs. And in the case of the port of Ferrol in Spain, they need the drones to monitor the traffic in the river and to inspect infrastructures, also to deliver packages to the ships, and also to broadcast instructions to the captains of the ships.
We are testing two different scenarios today. The first one is a cardiac arrest in the context of a car accident, and we will have 3 drones working on the scenario. 2 of them will be our eyes in the sky with cameras assessing the entire scene, and there's a third drone delivering defibrillator. So a lady rescuer who is present at the scene will use it to help the victim. The second use case is a mass gathering situation in Madrid at the Santiago Bernabéu Stadium, and the drones will help us guide the crowd in an evacuation situation using predetermined routes. We will use the drones with loudspeakers and color-coded lights to guide the people to the path we need them to be.
We are trying to use the capabilities of the swarm technology to identify vehicles with speed, especially speed, over speed in the lanes. We are also trying to identify distances in between cars and cyclists, for example, to being able to focus on these distances, which is the main cause of cyclist accidents and deaths. We are also going to try to identify special or reckless driving in the lanes. With this system, we are able to identify fluxes on the lanes and on the roads, and we can manage somehow the traffic fluxes in the roads. We can also send information to the drivers, preventing them from future events, closed lanes, and these kind of special situations. We can also manage having this information from the drones. Special operations in the road, for example, that we are not able to do it right now, with this flexibility that the drones can give us.
These potential applications are not currently covered by existing legislation. For this reason, Labyrinth is working to propose regulatory solutions to enable the full development of drone technology to ensure that all potential applications developed can become commercial solutions in the EU space in the future.
We have applied to different approaches when it comes to the review of the regulation. One of them is the top-down approach, where we have worked at European level. We have worked on regulation more related to the EU space. We have worked closely with Eurocontrol, that is one of the partners in the project as well. And the second approach was bottom-up, that it means identifying the different use cases in the project. We have analyzed what would be the restrictions that would limit this technology to be applied in the different safety scenarios.